Firefox implementation. Software engineers and the computer scientists, how they evaluate the requirements. So please go through that slide. So I'm not going to cover that again. It's some kind of information, right? So what is better? Many processors or threads, right? So that is the argument that they have when they are creating, when they are implementing the new version of the Firefox. So what is Firefox? It is an open source browser. Open source browser, commonly used browser. If you compare that with the Chrome, right? Also, it's we can say it's open source, and it is compatible with many operating systems, Windows, Linux, both, right? So you can install, download, install, and it's providing high-speed, secure web browser. So it's a client application. Server side will be the server application. So where now, just to have your idea now, if someone asks you to give an example of a client server application, so what you can refer is a good example is that web application. Websites, say simply websites. Those are working as client server application. Server side and the client side, two different applications are used for the communication. So if you go to the server side, what are the applications that you can run websites? Example. Yes, please. For the server side, what are the basic applications that you can run a website? We are in the second year, second semester. One will explain, one will ask that, okay, give me an example of a client server application. Yes? Anyone? Do you agree that this is an example, a good example is that web server or web applications? Example for peer-to-peer application? Example of a hybrid application? So those are the things that someone will ask. Hybrid, combination of both client-server architecture as well as the peer-to-peer. Please recheck, because you have the resources. Example client-server applications. Example peer-to-peer applications. Out of the syllabus, but anyway, I'm discussing this because it's very important to know those things, because those are generic things. So if you go for a server side, you can have the web server application. One good example is Apache web server. You need to run operating system there, say operating systems you can have like Linux, Red Hat Linux, or maybe CentOS. Or Windows server. This is the operating system. You need to have operating system to run the application software. So system software is that. The application software can be Apache web server, IIS web server running on the Windows applications only. Right? So application Apache IIS. Example, one thing you can select. Then you install that in there, and then you store or configure your website inside this server. So the web server can be configured to listen to port 80 or 443, and when someone requests for a website referring a URL, say www.nsvm web.ac.lk URL. When someone requests that, the DNS will map this to a server, and then the request will come to these ports, and then the web application will read those packets and direct to the folder where you have put your website. So this is we call the directory, or the folder where we have the site content, images, files, media files, whatever the things. Because that this application configuration file says, if someone asks for a website file of www.nsdm.ac.lk, refer the file path, like in Windows you have C:, program files, web server, whatever. Right? In Windows, in Linux you have, say, normally we have var www.html, where you have the, say, website NSDM. So that is the folder that you have all the content of that website. Your media files, so you can have that now. You can have the relative path names after that, like images. Inside that you can have like media. Them into that folder, and then direct the URL and DNS server wise you have to configure www.nsdm.ac.lk. It should be matched to the IP of the server, IP address of the server, and the configuration should go there. This is the URL and this is the folder. So then someone asks for that, the files will be checked in this folder, and if the file found, it will be directed to the requesting party. That is how the website is working. Maybe this is out of your system's fundamental, but you have to answer this kind of questions. So this is the server side application. Application details we discussed, that the system software, application software you have given here. And if you consider the client side application, client side, what is the client side application? That the user used to access the website. It is a, commonly you say those applications are system software, like can be operating system, can be Windows, Ubuntu, whatever the software, or maybe your Android. But here you need to have a client application to access the website. Yes, what is the application normally used? What is the application that you normally use to access the website? Yes, Pula? Web browser. So what kind of web browsers are there? Example is the Firefox. Example is the Chrome. Earlier we had the Internet Explorer, right? So several web access client application browsers are there. You can use them. You have to install them, and after installing the operating system, you install that. Sometimes this kind of applications are by default installed to the computer, like Chrome or maybe Internet Explorer IE. So those are there. The user can use them. So these two are totally different. Website, web server application is totally different to the client application. This is the kind of a tool that you try to access the content in the web server. So the communication will go in this way to here, and the request will come, or the request will come here. The response will from the other side to here. That is how you get the web page to the browser. So that is how when they are designing the web browser, they think that whether you need to have, because normally you are not accessing single page, or you are not accessing single website. You are accessing different websites. How you access? Sometimes you create a tab, sometimes you open that in a separate browser. You have private web browsers, private browsing, private windows. where your content or your communication will be something private. Data will not be saved, or maybe history will not be saved. So that is anyway you will create tabs, right? In a browser you can create tabs, separate tabs, and you can move, maybe go through the tabs and get to several pages, or you can open another window and access them. So now in this place, what the slides say, in the slides I have uploaded, they are the last 3 slides, just check that. It says that how the Firefox developers shift between the processors and threads. What they have selected is threads. Whenever the customer wants to go to another tab or browser, what they have done, they have created a separate thread for each and every access. So they evaluate the advantages and disadvantages. Process creation, the requirement, resource allocation, intercommunication between the threads and the processors. So please make a note that those are the things that you are evaluating when you select different processors, or maybe child processors, compared to the threads. Now, if you have any unclear things about it, this is something like a story. So whenever you have some kind of area that you can't understand, please get your requirement, or maybe please try to discuss with. Why we are saying that there are unfortunate situations. Now we have seen that fourth year. So today morning also I got a call from a student saying that can't you do anything to my results, so I am getting C minus. I have 2 C minus to this time, and then I will not be able to graduate with my batch. And what she is actually saying that because of that she will not be able to graduate with the batch. She has to miss the batch, and because of that she may need to pay the loan that she has to take from the Ministry of Higher Education. So this is unfortunate. But what they have created, when you don't know that, so that is why I am saying, you feel that just keeping the unknown areas without asking from the lecturers, without discussing, you just keep it with it. What will happen that it will, we can say that it will be added, cumulate. එකතු වෙලා එන්නේ මේ ඔක්කොම අමාරු දේවල්. අන්තිම අවුරුද්දට වෙනකොට මේ ටික තේරෙන්නේ නැතුව ගියාම හොඳටම අමාරු. දැන් මේ you are in the second year, second semester. Some of the parts may be not clear. Please come and discuss. Or you can, even if you are feeling that okay, feel shy to come to the lecturer and ask that again and again, you can use whatever the media that you have, resources, go through that. And if you have any unclear things, please send a mail, or please discuss. Because you should be able to, you should have a very clear picture of whatever the things that you are having in the IT field. An unfortunate thing is when you are asking questions, you are not trying to respond. You believe that that is something, the kind of a value that you have. No, that is not. Unfortunate, right? Because finally, when you have at least more than 1 C minus, I know that you are not going to get this kind of marks. You are maybe having A pluses, B pluses, or B minus at least. But why? Because of some reason. So there was a complaint, not a complaint, request. One student having maybe affected with COVID, and because of the COVID, the complications are higher. So he was not able to actually get the required information, maybe attend to the classes and go through the lecture notes. We don't know. Those are unfortunate situations, but there is no any kind of favorabilities on that, right? So please try to grab whenever you have the time, whenever you have the requirement, opportunity, you try to understand. Don't underestimate. Sometimes you have missed your A level because of that. Now you are in a totally different field. Just forget about the past. Don't worry about A level or O level or whatever. Now you are in a totally different stream. You have a path, right? You have a direction. So please try to, because now whenever you are getting mature, what will happen is that there won't be very small, freedom, or maybe you are having very small flexibility. You have to do that, right? You have to get the marks in that way, and then there's no any flexibility there. Even the student is having COVID, COVID victim. So only the given time, or maybe kind of a medical reasons, because of the medical reasons, that time is not covering the entire exam. So they have to attend the exam somehow, and then maybe the exam results was like maybe like from the 100, it was like 10 or 9 total marks. So there was another subject, entirely the marks was 0. I think I shared that earlier. After 4 years of learning, that he was not able to mark or get a single mark for that subject. So it is something a kind of a unfortunate situation, and we have to actually consider it a very serious matter. Lecturers දුක් වෙන්න ඕන. අවුරුදු 4ක් අපි ගන්නලා සබ්ජෙක්ට් එක අවුරුදු 4න් එළියට යන ඉන්න ළමයෙකුට එක සබ්ජෙක්ට් එකකට බිඳුවක් එනවා. Not a fault of whom we are going to blame. Academic structure, curriculum, no, because they have wasted time. හිතලා හරි නොහිතලා හරි වෙලාව නාස්ති කරගෙන. ඒ තේරෙනකොට ටිකක් කල් යනවා. ඔබ හරි අවාසනාව. හරි. පොඩ්ඩක් ඒකට කල්පනා කරන්න. දැන් මුදම දේ තමයි academic activities එක day to day updates අරගෙන යන්න. Day to day you get the idea from the lecturer, or you can maybe discuss among yourself. දැන් මෙතන තව ප්‍රශ්නයක් තියෙනවා. ඒක unofficial අපි කිව්වොත් මෙහෙමයි. අපි හිතමු තැනක ඉන්නවා ළමයි වැඩි ප්‍රමාණයක් 70% keen to learn. 70% want to know the things. What will happen to the remaining 30? That remaining 30 will automatically go with that 70%. වැඩි හරියක් මේව ප්‍රශ්න විසඳගෙන එළියට යන්න කියලා කිව්ව මතේ හිටියොත් ඒගොල්ලොත් එක කට්ටියම යනවා. ඒකට අර නමුත් ඔගේ අනිත් පැත්ත උන 70% like to just waste the time. What will happen to that 30%? After 1 year, the 30% will reduce to 20. After 2 years, the 20% will reduce to 10. And then finally, no one want to, go through that. Unfortunately, because we have a new temperature. So that is why I ask a simple question. What are the basic components? What is a good example for a peer-to-peer, client-server application? What are the components required? That is what I discussed. Web server from the server side, client web browser is the client from the client side, right? So please, no issue, right? We have very small crowd here. Let's make an example, extend example for a peer-to-peer application. So there's no server, there's only one kind of application. We can say that peer-to-peer application. BitTorrent. A good example. Read about BitTorrent. Read about other file sharing applications. So there, what will happen? The P2P. These nodes will be sometimes like a server, sometimes like a client. This can get the details from this server while he is actually supporting to another server, another node. So this is peer-to-peer. All applications have the same privilege, while one is getting service from the other node, and that server, that node can serve to the other server, other node in the network. So this is by file sharing, right? We don't know. So that is how it is propagated. That is how it is expanding. So it is very easier to expand Why? Because there is no such a single point, right? But security manageability is very low. You know that is there because we don't know someone will take our files, if whatever the files you have opened to that application will be there. While you are downloading the file to here, that the downloading content may be shared with the others as well. That is what happens. So please read about it. So what is a good example for hybrid mode? Both client-server application are features and the peer-to-peer application features are there. That is because the hybrid. Example, anyone having any idea? Just try to remember. Sorry? What I where? Decentralized. Okay, right. So that is one example. But the other, very common example is, if you consider this, IP telephone. Or we can say voice over IP. Why we say that? Because you need to have a controller, we call the SIP server, Session Initiation Protocol server, which is maintaining the directory of the clients. So they are authenticating with that. Their IPs and their numbers will be there in the server. Initially, the client will be there. Those all are running on the IP network, right? IP network. So this is registered with the SIP server. So you are becoming a SIP client server. SIP client for this service. You want to send messages to another server, another client in there, so you can be say yes at nsbm.ac.lk, believe that nsbm.ac.lk is providing us IP voice over IP service. So this is the person logging here. So you want to call to another person on internet, and he is also having the connection or maybe a username like that. So the account there. So what will happen there? Initial communication, authentication will be gone through this server, and then when it is sending data, it will be directly through that real-time protocol. So Web3 architecture is also having the similar, because advantages in both systems can be grabbed and then develop new concepts. Now, who is developing these concepts are the computer scientists, computer engineers, not the hardware level but the software level. That is maybe you. You have to get the idea. Okay, right? Just we were discussing about the processors and the threads that we have. We are trying to create new, or maybe get the CPU time by initiating another process. Okay, so what are the ways that is like creating a separate process and creating threads, multi-threading application. Both having advantages and disadvantages. So you compare, you try to evaluate your program, right? And then try to design how you are going to cater to many customers. For example, this web server, we discussed that it is not only one-to-one service, right? One-to-many. Hundreds of customers coming to that or accessing the same website. Now, yesterday, our Info was one of the most accessing websites. So that server is here. So whenever you try to access that, how to cater the customers in that way. How to cater now, whether they are going to create separate processors for each and every customer, or whether they are having separate threads to handle customers. Whenever the new customer requested, the page and the content who is going to handle it. Because they can't mess up, right? One will actually getting the certain data, the other one will get the other data. Right? So we are not going to mess with the communication. So that is how it is handled. Right? Any questions that you have related to that? If not, we can get into the new topic, that is resource allocation and scheduling. So we were having the idea about the resource allocation. Resources are in the computer system. What are the resources that we have? We discussed many. Yes, example. What are the resources, Puta? What is the most important resource in a computer system? CPU. You said that. Is that you? Oh. Anyway, CPU power. Why? Because it is working in a very high speed. And there are other resources like network is a resource, memory is a resource. Why we say a resource? It is because we have limited number of maybe content or maybe kind of again we have to say that maybe assets. So processor normally we have what? Because can you remember the Amdahl's law said that having more processors not giving the desired output, because inter-process communication and algorithm and the program differences, right, and then getting the common output, those are the problems of many processors. So the computer scientists wanted to have the benefit or maybe running the system in a very efficient manner, efficiency and effectivity. I think you should know that. So the CPU is very important resource, and we have memory. Again, we have very limited resources. We have registers, we have cache memory, we have hard disk. Compared to the other resources, maybe your hard disk is much higher, but again it's a limited resource. And very importantly, now we have the network-centric computers where you are connecting to outside with the network, to the network with network interfaces. Again, the bandwidth is a very limited resource. Those are resources. Now, how we are going to allocate the resources? Who should get the resources? Maybe who should get the priority? Who is going to control? For example, now you are accessing Facebook and you are accessing QuickInfo, and you are accessing YouTube. Now, what browser or what tab should get the most data? Who is going to allocate the bandwidth? Who is going to define? Now you can send the request. Now you can send request and so on. Who is going to allocate the resources? So those are the resources. If you consider the network as a resource required, you consider the memory. Again, you know that when your application can be stored or installed in the hard disk, and then whenever you click that with the required memory requirement, this should be filled, or maybe when it is actually loaded to the memory, it becomes a process. We discussed that. I am always remembering the things. Otherwise, it is a program. You double click that, or somehow, or maybe by the system software, it will be loaded to the memory. Once it is loaded, so there can be several processors here and there loaded. Who is getting the other resources like registers and the CPU? As a background process, there can be several processors running. If you click Alt Control Delete, you will get the task manager in Windows system. What will happen is that the task manager, you can list down the running processors. If you feel that the compute is getting slow, you may be deleting or maybe removing the processors by ending them, terminating, right? Resource terminations. So we discuss about the details about these processors. PCB, process control block, where you have the details about each and every resource that it is actually using. So whenever the process getting any kind of a block, because of a time issue with the accessing the other resources or network. Sometimes the processor will, or maybe the operating system will use the CPU power for another process. Because this has a problem in running, it is blocking. It needs some time to read some data, or it is waiting for user input, or waiting for a network input. Because of that, this process is now not in the running state. It will be IO waiting, or maybe ready. Wait, can you remember that diagram? Always remembering the things. Very, very easy to remember, right? You have the running processors, you have ready but not running, and you are having IO waiting. What are the IOs? Maybe hard disk, maybe network, or maybe user input. Waiting. Once you get into that, it will be moved to the ready state. Still not the given the priority, or maybe given the resource like the CPU. So the operating system will select whatever the process hanging here and then allocate the time. At one time, normally this process can execute only one command or one instruction belongs to one process. Similar to you, right? You can't answer the questions while you are listening to music, while you are drawing a picture, image, or kind of a drawing, or maybe while you are playing the guitar. Maybe you have the, no, for example, while playing the guitar, you are sometimes you are singing. One process will be automated, right? Maybe while you are swimming, you can sing, but the thing is now again there can be at a certain process, if you consider that the priority and mainly focusing point will be one, and the other one is automated. Automated. Sometimes you are missing that, and one process can be not giving the desired outcome. Some are going together, but some are having some problems. Like say, can you do a calculation while you are listening to a phone call? Right? I think you have seen, if you are focusing well, your resource utilization, if you do that in a very proper manner, it will be okay. For example, as mentioned earlier, like maybe the shopkeeper, the person who is actually there as Mudalali, he is actually responding to each and every request, coming here and there, but still doing the calculations, answering the things, giving some goods and so on. But at a particular time, he is only performing one, but the thing is, he is switching between the processes very well, without maybe the user will not significantly identify that he is not responding to me. If the customer is saying, believing that, okay, maybe customer is getting the idea that Mudalali is not responding to me, he will just go outside. Now, for example, in a normal fair in a village, what will happen? There's a person, Mudalali, he is measuring the things, getting the balances, answering the questions of the customers. බෝංචි කීයද කියලා අහනකොට ඒකට උත්තර දීලා බෝංචි එක තව දානවා එක්කෙනෙක්ගේ මල්ලකට තව එකක් ලෝඩ් කරනවා සල්ලි ගන්නවා එක්කෙනෙක් විනාඩියක්වත් බලන් ඉන්නේ කස්ටමර් කෙනෙක් බෝංචි කීයද කියලා අහලා බෝංචි එක කියන ගාන කිව්වේ නැත්නම් ඊළඟ තැනට ගිහලා බලපොලේ යනවද බලන්න ගිහලා බලන්න මොකද දේව example. So the person who is actually keeping the system alive, right? Keeping the system alive is very important, otherwise some processes will get idle. So you will need not say that the system is very efficient. Right? But සමහර තැන්වල ඉන්න මුදලාලා ඉන්න එක්කෙනෙකුගේම බඩු කියලා කියන ඉවීක දෙනවා අනිත් මිනිස්සු බලන් ඉන්න යනවා. මේ මොනසගේ බඩු කොට එහෙම ඉතුරු වෙනවා. Good examples there, right? The other thing is that I want to highlight that, so I think you got the evaluation forms, right? So that is very good kind of a, that is what you can do for the lecturers as well as that is what you can do for the academic program. You evaluate the lectures, I mean not the evaluating the lecturers, you can just evaluate the program, right? What are the things that you are suggesting to improve? Very important, I think already one response was there, I just checked that yesterday. So please give your feedbacks about all the modules that you are having. What will happen is that it will be useful for the lecturers as well as the program coordinators to focus on lagging points, weak points. So then your juniors will get the advantage. They will get more customized, more developed content as well as the delivery, right? So very important, please try to, if you have the time, please try to give your feedback, okay? Will be useful for not only for me but also for the entire academic and also for the NSPM green units. That is very good, right? Okay. Back into the things. Now we have the idea. I think so. We will without these having the idea here, you will not be able to actually get the actual meaning of these terms, right? Try to understand. So what we are going to discuss today about process resources. Now we have already done. So I'm not going with the slides maybe. Because whenever you need the idea, we will discuss. So requirement of process scheduling queues, process scheduling algorithms. How you are going to maintain the queues or schedule queues? Here the queues are there, and algorithms. How you are going to select from there to here? What is the algorithm? Algorithm is the normal process that you are maybe used to make complete a task, right? We'll discuss. Resources to run a process we have already identified. The process needs certain resources such as CPU, memory, or other I/O to perform tasks. Network sockets, files, very important, right? Very important to know that. So when processes running in a system, the resource utilization needs to be monitored. Why? Because you can identify. Now, resource utilization. Operating system, we said that the operating systems are actually doing the control, right? So he has to get the idea that what processors are using, maybe like what are their limitations. Whether they need CPU, whether they need to write something to the hard disk, whether they are actually waiting for the user's input, whether they are waiting for some kind of input from the data from the network card. So monitoring should be done. Now in a normal factory, get into the factory keeper will look into the flow, right? He will check whether who is actually waiting, who is actually having huge load, what are the resources limited, what are the resources that you have more than enough, can't we use them and then maybe expand the process or speed up the process. So that is the keeper, or maybe the timekeeper, or the manager who is looking to all these resources and the utilization. The very important, why? Because you are trying to provide the computer system more efficient and effective. Otherwise you can just hang around. මේක අපත් දියුණු කරන්න ඕන කමක් නැත්තම් අපිට ඉතින් මේ ගැන එහෙම හොයන්න ඕනේ නැහැ. right? කම්පැනියක් දුවනකොට ෆැක්ටරියක් දුවනකොට ෆැක්ටරි විශ්දයක් බලන්න නැත්තම් if no one is looking to the resources and how they are working, people will do whatever they want. What will happen? Maybe after few months the entire process will collapse and the factory or the organization will be bankrupt. විනාශ වෙලා. ඇයි? Proper monitoring was not there. Similar thing happened to the computer. Computer will not destroy, but no one will use the computer. So you are the people who make the computer systems more effective and efficient. Computer scientists. Otherwise, software people will do whatever the things that they want. They will write programs which some are very much highly resource consuming. Just hanging around, loading so many resources, right? Trying to connect several databases at a time, trying to create database connections. For a one connection, they are not going to close that and just open other few. what will happen? Always the resources will be wasted, and then the processors will be kindly we can say very high loaded, and then other processors will not be able to utilize. අනිත් process වැඩ කරන්නේ නැති වෙයි. ඔක්කොම හිර වෙලා තියෙනවා. සමහරවල් බලන්න කම්පියුටර් එකට open කරලා තියෙන ඔක්කොම process I don't know whether you are I don't think that you do this, but normally if you go to a simple end user අර නිකන් අපි හිතමු company වල ඔයගලට experience නැහැ. මට experience තියෙනවා මේ සමහර වෙලාවට අපි හිතමුකෝ computers ආවේ 1990s වල ඉතින් like අපි හිතමු අවුරුදු 50 55 කෙනෙකුට computers they are not having the computers while they are having their higher studies, or maybe while they are doing their A level. So they just kind of a people who try to do everything in a manual form. They are very good at manual processes, but they don't like to have the computer because they are having some kind of a fear. Technology එකට බය වෙන කට්ටිය ඉන්නවනේ. ඒක ඒගොල්ලන්ගේ දුර්වලතාවය නෙමෙයි, ඒගොල්ලන්ගේ හැටි. ඒක තමයි විදිය. ඉතින් මේ computer එකේ ඒගොල්ලෝ what they are doing, they don't think that the computer is also having resources. Whenever they want to open a browser, they open a browser, and without closing that, these browsers will be very resource consuming. They are loading and they are loaded. So whenever you go there and search for the browser, there will be like 20 plus browsers open. So what is happening? When the browsers are opening, you know that the memory will be actually taking huge lot of portion. So memory is filled with the processors in the browser. Sometimes very heavy processors are like word processor application, word processor, PowerPoint, Excel. You go to a very old kind of a account clerk who is using the computer. What will happen? He's just opening several Excel forms, and then after sometimes he is complaining that this computer is very slow. Why? Because these running processors need the resources. These resources are limited. So whenever the computer, now what will happen now? Initially he will say that the computer is fine. After few maybe minutes or after few hours, what will happen? He will complain that the computer takes very long time to load another application. Now they are not saying that I have so many applications open. They will say that okay, when I try to open a Word application, it is taking 1 or 2 minutes to open. What is happening? The process is that the memory is now filled with several applications, and whenever he tries to open another application, what will happen is that the operating system has to get some free spaces from the memory. So what it will do, it will select a process which is actually not running actively now, and then putting them back to the hard disk as keeping another area called virtual memory. We'll discuss them as well. Another area is there like virtual memory. He will shift all the content to the virtual memory and make that place free. Right. Now then their data will get into this now. So this is a huge process. It needs to access the hard disk, where you know that accessing hard disk is not such easy, right? Accessing random access memory is very easier, but we know that accessing registers are very fast. Compared to that, this is very slow, but compared to this is much more slow. Writing the content to there takes huge lot of time, and then loading the required memory or details take another time. So that is why it's complaining. Sometimes even you have seen ඔගොල්ලෝ එකපාරක් මෙහෙම ලෝඩ් කරලා තියෙන කම්පියුටර් එක මෙමරි මේ තව මැෂින් තව එකක් ලෝඩ් කරන්න අපි දැන් හොඳට හොයලා බලන්න සද්ද ඇහෙන්න පටන් ගන්නවා hard disk එක read කරනවා. හිතන්නේ it is not only because reading the content, but writing back to the virtual memory. Two very much time consuming processes will take place. Because of that, these computers will, the user will be frustrated. Why? Because computer is not responding like. Sometimes if this process getting a block, the computer stuck. Entire computer will get stuck. you will not be able to run anything. Everything stuck there. Auto control delete gala and memory very poor use not responding to an application. You have to close by memory. Forceful. That is what you are doing. You have all these experiences. Only thing is that you have not thought why this is happening, but now you have to focus on. Right? So if you go to details like here, monitoring process, as mentioned earlier, manually you can check the CPU utilization, memory utilization, network utilization, but automatically all these parameters are measured by the operating system. Trying to minimize the thing because there are several resource allocation algorithms, resource allocation processes. Okay? So in Linux, command like ps-aux, netstat-net, lsof, right? So those are the commands that you can, as a user, you can check how the resources are highly utilized or maybe utilized in the computer system. For example, if you go with this kind of a outcome, you will see the processes are defined by the process ID, that is the unique ID that you have, right? So similarly, who has initiated or root means the operating system by default, and the virtual memory and the other parameters like the CPU utilization, memory utilization as a percentage. So sometimes you will see that there can be a process which is actually highly, maybe 90% of the CPU is utilized by that application. Or maybe the memory, 70% of the memory is used by that application. So you can monitor that. The computer, especially if you are having the Linux kind of operating system, you can get the idea and then immediately you can close that by just calling kill -9 the process ID. If it is a parent process, as we discussed, the child processes will automatically get deleted. Right? So that is how the things are happening. Just have the idea. Just have the idea. So you should know. I mean, don't take this as a very boring content. You always try to match that with your day-to-day experiences. Then you will get the interest. ටෙක්නිකල් දේවල් ඉගෙන ගන්න ගියාම ඉතින් ටිකක් අර එපා වෙන ගතියක් තියෙනවා. ඔක්කොටම වඩා අමාරු මේ එකයින් පස්සේ ඉගෙන ගන්නවා කියන්නේ. දුවගෙන එනවනේ කාලෙදි මමත් එහෙම තමයි. මන්ට කාලය ඇවිල්ලා ඉඳගෙන කූල් එකේ මුකුත් කියවන්න නැතුව ඉන්නකොට ඉතින් ඉතිමත් එනවා. ඒක අර අපි හිනා වෙන්නවත් නිකන් ඒක එහෙම වෙන්න ඕනේ. ඉතින් අපි වතුර බීලා හරි මොනවා හරි බීලා අහන් ඉන්න ඕනේ. Now you don't have the recording as well. ඒකින්ද තමයි මේ ප්‍රශ්න අහලා කතා කරවන්න හදන්නේ ඉතිමත් යන්න. ඉතින් ඒක අහන මනුස්සයට එපා වෙනවනේ. ඉතින් කතා කරන්නේ. අර එන්ටර්ටේන්මන්ට් වලට වෙනම ගානක් අපිට ගෙවන්න ඕනේ. ලෙක්චරර්ස්ලා ඒකට පොඩ්ඩක් නිින්ද යන්නේ නැතුව තියන් ඉන්නවනේ. ඒක අපි දැන් පුළු වෙලා. දැන් නිකන් කන්නකො ඕගොල්ලෝ කතාවක් කියලා ඇවිල්ලා ඉස්සරහට ඇවිල්ලා කියනකොට මිනිස්සු නිකන් නුන් යවනවා නම් නිදා ගන්නවා නම් නිකන් ඉන්සල්ට් එකක් කියලා නිතරම අපි ඕගොල්ලෝ අපි නම් එහෙම හිතන්නේ. ඒක මේ කරන්නේ. හරි. ඉතින් අර පුළුවන් තරම් උනන්දුව මොටිව් you have to keep that. හරි පුදුම ප්‍රශ්නයක්. ගන්න මේවත් එක්ක නිින්ද යනවනම් පොඩ්ඩක් කියලා ගිහිල්ලා උන් හොදගෙන ඉන්න මේ වෙලාව අපි පිළිගන්නවා මේ වෙලාව ගන්නන්න පුළුවන් වෙලාවක් නෙමෙයි. ඒකනේ ඉතින් ඉස්කෝලේ වල එකමාරට ඉවර කරන්නේ. නේ? එකමාරට වෙලා එකමාරට ඉවර කරා. පැය 6ක්. ඉතින් මේ වමනට අර ඉන්නේ මෙහෙම බබාලා නෙමෙයි කියලා හිතලානේ අපි අර එහෙම ගාලා. You have now. We call that university. මොකක්ද ඒක තේරුම? University කියන වචනේ ඒක එකපාරට සරසවිය කියලා හැදෙන්නේ කොහොමද කියලා දන්නවද? How the heavy කියලා. How the කිව්වේ වචන. University how become සරසවි. ඔයාලා බලන්න. සරසවි. මොකද ඒකේ තේරුම? University කියන එක නම් meaning එකක් තියෙනවා. Right? So universitas කියලා. ඒ කියන්නේ the place where the scholars get together. එහෙමයි කියන්නේ තුනේ බලෙන් හිතව ගන්නලා දෙමව්පිය සල්ලි එහෙම නෙමෙයි. ඉගෙන ගන්න ඕන අය ඇවිල්ලා ඉගෙන ගන්න. එතකොට එතන එන මිනිහා නිදා ගන්න නේද? ඒගොල්ලෝ ඉගෙන ගන්න. එතකොට මේ මිනිස්සු ඇවිල්ලා කතා කරනවා මේ වගේ this is not formal lectures, discussions, right? Arguments. So that is how they came into a place and then discussed that and improve the knowledge. But now we have a very formal things where we ask the people to come and then we try to forcefully install the things to their memory. Right? Some maybe 70% not fruitful, but the other 30% take the things and go. The important thing is, my dear students, try to become the, maybe if you have the batch, whatever the discipline, don't consider engineering or computer science or networking or whatever the discipline. Try to be within the first 20%. Easily get the jobs for any degree program, because the degree programs are not designed just in an ad hoc manner, because there are some requirement from the industry. So then they will try to build or maybe map the industry requirement and the knowledge and try to bridge the knowledge gap, and then maybe come up with the degree program. And then normally we will assume that the industry may be required 30 people, say just assume 30 people, and then with the future requirement there will be 20, another 10 within few years. So that is how you enroll to the program. That is how the program is actually allocated. So then you are getting to that, and maybe because of the requirement you will be having another part, like say another 20 or 30. So altogether you have 70, but you have only 40% or 40 people required. And out of that 40%, if you consider that 16 people will be immediately get the jobs, because they are in the top. So that is why we say that at least try to be in the 20% of the student group among the entire batch or among the entire graduates in the country, right? So they will immediately getting the opportunities from the industry, and then eventually all will get, but you will not have any kind of a issue when you are in any field, when you are in that within the first 20. So try to get some things like that. So that is why you are trying to get the first classes, right? Or maybe second uppers. Because they are evaluating that. Industry is asking, okay, what is your grade? So first class. So if you want to be an academic, always this first class matters. First class matters. Why? Because when you are going for a PhD, when you are going for an academic interview, they will conduct interviews for first class people in a different time slot, second uppers in a different time slot, second lowers in a different time. Even they are doing that as well. For the academic purposes they will, but not in the industry. But they are very happy to have the first class people. Okay? Right. So this is resource allocation. So we are here and there, and then we move to some other area. Anyway, all required, right? මේ කතා කරන හැමදේම සමාජලට වැදගත් වෙයි ජීවිතේ හැදෙන්න. Academic දේවල් විතරක් නෙමෙයි. So how CPU can be shared by a set of processors? Not the processors. SO දැම්මොත් ඒ කියන්නේ processor, different process, server, different CPUs, but how the different processors utilize the resources. So on a single processor, though it is not possible to have processors or threads truly executed at the same time, so you can't do that truly, because one at a time, one process instruction will be executed by the program. Maybe you have the micro instructions, then some part of the instruction can be divided, or maybe they can be divided into smaller parts. So one small part will be executed in the one clock cycle. Right? That is the instruction. Control signal should be there. In this case, the CPU is shared among the running processors or threads. So process scheduling techniques divide the CPU time and yield the illustration of parallel execution. So we call that concurrent computing. So somehow with the techniques that we have, we are lucky enough to we are lucky enough to share the resources, network, process, memory among the processors and or we can say threads, and then look like parallel execution, parallelly done, but actually it is not like. It is running like a different architecture with the concurrent execution, not parallel, but seems like parallel because we are very slow moving creatures. We can't just identify that whether they are running in the same time, at the same time, or we have. Do you have any questions? Okay. So please check. Right. So now concurrent computing. Concurrent computing is a technique in which two or more processors run in the interleaved fashion through context switching and complete in an overlapping time period by managing access to the shared resources. Definition. You get the idea. So it is technique which two or more processors start in the same time, but using the important concepts called the interleaving and context switching. Because of those techniques, what will happen is that sometimes they will be completed. The process, two processors or many processes will be completed within the same time. Start करना process 1 එක 2 එකක් ඉවර කරනවා. පළවෙනි එක ඉවර කරලා නෙමෙයි දෙවෙනි එක පටන් ගෙන කරන්නේ. එකම අතරදී දිග මාරු වෙවි කරනවා. අර බුදලාලි is doing like discussing with the customers, giving some support to the customers, collecting money. එකම ටයිම් එකේ මොනසෙ එකයිනේ කරන්නේ කොහොමද? කළ බලන්න මේ මොනසෙ සල්ලි ගන්නකොට සල්ලි ගන්නවා 100 නැත්නම් අර මොනසෙගේ I gave 1000 rupees. මොනසෙ ගන්නවා මේ ගත්තේ 500 කොලයක්. And counting, ඉතින් ඔක්කොම බිස්නස් එක වැටෙනවනේ මේ මොනසෙ වරද්දලා ගන්නොත් ඒ. සතේට රුපියලට මොනසෙ ගන්න මෙහෙම කරනවා. Right? So he can't do that while maybe some automated ඉබේ උත්තර දෙනේවා තියෙයි බෝන්චි කීයද කියලා කොහොම කියනවා ඇති ගන්න. ඒක ඔන්නේ තියෙන හින්දා ඒක. හැබැයි ඒක වරද්දන්න කියන්නේ නැත්නම් කස්ටමර් ආගියු කරනවා. වැරදිලා අඩු ගන්නක් කියලා බෝන්චි කියලා වැඩිකොට ඒ ඉස්සලා කිව්වේ අරගෙන මට එපා කියනවා. ඉතින් බලන්න කොලකට බඩු ගන්න කරන්නේ මිනිස්සු ආගියු කරන්නේ නැහැ. බාගයෙන් කරන්නේ නැහැ. ඒ කියන්නේ good example of a real time multi or concurrent processing is a very good example of the seller in a market. You can people name example. රුපියල් 20 කොලයක් හරි 50 කොලයක් හරි 100 කොලයක් හරි ඉන්න දෙන්නොත් මොකද කරන්නේ? බාර ගන්න නැහැ නේ. ගිහලා බලන්නකෝ මේ ෆුඩ් සිටි එකට එමු ගිහින් නෝ කියන. කඩේකට නෝ කියන. ඉතින් අපි හිතනවා නම් පොලකට ගිහින් පුළුවන්. 20 කොල දෙක තුනක් දාලා කොහොම ඉතින් ඉතින් කලබලෙන් ඉන්නකොට උදාහරණ දෙනවා. 180යි කිව්වම ඉතින් 100යි 20 කොල හතරකුයි දෙනවා. එක කොලයක් පොඩ්ඩක් ඉරි. මේ මිනිස්සු ගන්න. මිනිස්සු ගන්න නැති. Hey, they actually, they do whatever the things with the maximum focus. Check kala balanu takka ආනන්ද මේ කරන්නේ. ඉස්සර වෙනිසර. Okay. Right leading මේ වෙන්න පුළුවන්. But they are, what I want to highlight is that they are focusing. So that is not multi-process like several mudalani is there. One is to collect money, and one is to measure the things, one is to give the answers to the queries asked by the customers. So කොහොමද බං කරොත් මේ මිනිස්සුන්ට ගෙවන්නේ? කරන්නේ. Right? So likewise you are not providing or maybe having more processors, right? But using the interleaving. Interleaving එක කරොත් ඒකත් අපි use කරන දෙයක්. කෙනෙක්ගේ බඩු කිරණ ගමන් තව කෙනෙක්ගෙන් ප්‍රශ්න අහනවා බඩු කිරණ මිනිස්සුන්ට හිතනවා මගේ බඩු කිරණ වැඩේ තමයි කරන්නේ කියලා. ප්‍රශ්න අහන මිනිස්සුන්ට හිතනවා මට උත්තර දෙන්න තමයි කරන්නේ. ඒ කියන්නේ you try to keep the attention of these two processors simultaneously with a very high priority manner. computers are running in that manner, right? And context switching. but context switching කියලා කියන්නේ මේ පැත්තෙන් ගන්න දේවල් වලට ඒ උත්තරේ දීලා එතනින් ඒක isolate මේ content එක මෙතනින් ගිහලා අනිත් මොනසෙට උත්තර දුන්නාම මම කීයක්ද ගන්නේ කියලා එහෙම අමතක වෙන්න බෑ. You have to keep the status of that particular process. You have to remember that he has taken 2 kilograms of beans. And then I have to calculate I ගිහලා කීයද දෙන්න කියලා ආයි කියනවා මේ කොච්චරද වෙන්නේ කියලා. Hey, you keep the status of the each and every transaction separately. So that is why they are genius. I mean, not in the educational process measures, but in the normal, maybe like the merchant level. Very good. Handling multiple requests at the same time without violating their boundaries. Right? So these two concepts, interleaving, not completed one thing and then start the other thing, completely you will see that it will not work. Because no one will like to wait for a longer time, right? Customer wise and the process wise. දැන් ඔයගොල්ලන් හිතලා බලන්න මේ කම්පියුටර් එක ඔයගොල්ලෝ නිකන් එක process එකක් run වෙන ගම වෙන process එකක් run වෙනකොට message එකක් ආවොත් there's a one process running, please complete that or shut down that to start another process කියලා આવොත් මොකද වෙන්නේ? Use කරන්නේ. You are not going to use the computers. So you start whatever the process right now with the computer, it will boot up, it will start. It will not say that okay you have another process running, waiting for the CPU to execute. No, it will be there. It will be using but use of the concepts like the interleaving. So it doesn't necessarily mean that the multiple processes will be running at the same instant, even if the results might make it seems like it. හරියට නිකන් output එක පේනවා එහෙම වගේ කියලා. හැබැයි එහෙම නෙමෙයි. හොඳම example එක තමයි නම් music එකක් අහන ගමන් තව මොකක් හරි මේ computer එක system එකක් වැඩ කරවන්න ඕන. music එකක් computer එකේම දාලා. දැන් music එක කැඩි කැඩි ඇහෙනවා. There are also executions because you have to get the data and convert them and maybe convert them to a wave file and then get the desired outcome. එහෙම නේද සින්දුව play වෙලා ඉවර වෙනකන් ඉඳලා අනිත් වැඩ කරනවා. word එකේ you type your assignment while you are listening to a music. So how the things are happening? Especially that the processor is running in a very high speed. අර අපි කියන්නේ fan එකක් අර කැරකෙනකොට මේ high speed කැරකෙනකොට අපිට පේන්නේ ඔක්කොම එකම විදිහට වැහිලා තියෙනවා මම. right එකම නැත්නම් අර කියන්නේ අපි මීමැස්සෝගේ මේ අත්තට පේන්නේ නැහැ කියලා ඒක නෑ වේගෙන් ගැහෙන්නේ. අර කුරුල්ලෝ හැමින් බර්ඩ්ස් එතකොට ඔයගොල්ලෝ අත්තට සල්න වේගෙත් එක අපිට ඒක බලා ගන්න බෑ. ඒ වගේ අපිට හිතෙන්නේ right ඒ වගේ ස්පීඩ් එකක් කම්පියුටර් එකේ තියෙනවා. You have that very high speed like you know that gigahertz means ගණන් එහෙම හැදුවා ගිගා කියන්නේ 10 to the power 9. How many cycles? 10 to the power 9 cycles. Now theoretically if one say down there මේ මතක තියාගන්න clock per instruction CPI if it is one cycle that means this cycle once you get into that is the time required to execute that command instruction. You will not see that the difference because we are very much time consuming because we are as human beings we are measure the clock or maybe the time in seconds. අපි තප්පර ගණන් වලින් ඉවත් බෑ. තප්පරයක්. අපි කියන්නේ අසුරු සැනින් මේ වගේ. ඒක තප්පරේ විතර අඩුයි. අපි දන්න අඩුම කාලය ඒක තමයි නිමේෂයක. සිංහලෙන් එහෙම. ඉංග්‍රීසි වලින් කොහොමද කියන්නේ? ඉංග්‍රීසියෙන් අඩුම කාලයක් කියන්නේ මොකක්ද? කොහොමද? fraction of a second එහෙමත් තියෙනවා නේ. fraction කියන්නේ ඉතින් තප්පරයෙන් කොටසකින් අපිට වඩා හොඳ ලස්සන වචන තියෙනවා. අසුරු සැනින් කියලා කියන්නේ අසුරු සැන කියන්නේ මේ. ඇහිපිය හෙලන නිමේෂයකින්. මේ කියන්නේ රචනාවල අපි නේ අසුරු සැන. ඒ වගේ අපි කියන දේවල්. හැබැයි ඉතින් අපි කියන මේ කාලේ කම්පියුටර් අඩුයි. ඒක පැහැදිලි මෙහෙම ගහන්න පුළුවන් තප්පරයකට කීපසරයක්. SP හෙලන්නත් පුළුවන් තප්පරයකට කීපසරයක්. ඒක තමයි කරන්නේ. මේ තමයි අපේ තියෙන අඩුම වේගය. සෝරි වැඩිම වේගය. අඩුම වේගය නම් ඉතින් අවුරුදු ගණන් විභාග කරා. විභාග සමාජ ෆස්ට් ට්‍රයි කරනවා ඒක අවුරුදු වලින් යනවා. ඒක process එක run වෙලා කරලා. ඒක අපි because our life span එක අවුරුදු 70 අපිට ජීවත් වෙන ගමන් ටික කරන්නේ නැත්නම් කම්පියුටරේ බාරදුනොත් එහෙම දවස් 3 විතර වැඩ ටිකක් කරලා කසාදත් බදලා ළමයි උත්සම් වෙලා මැරලත් ඉවරයි. අයියේ ස්පීඩ් එකෙන් ඒක යනවනේ නේ. කරගෙන ඒක තමයි කියන්නේ. You should not worry, but thing is that is how the things are happening, right? So it doesn't necessarily mean that the multiple processors will be running at the same time, same instant, even if the results might make it seems like. Pool වැඩි නම් අඩු කරන්න. මොන දෙකක් දාලා තියෙනවා. Pool එක වැඩි නම් අඩු කරන්න. You can just stop one. One is concurrent versus parallel. I think you have the experience. Concurrent is like you execute the, now this is like the coffee machine. Here you have two coffee machines, resources allocated, and then you can have the queues there, right? One by one will be catered. Then you are getting the coffee there, because you have the two resources, like two processors. But when you have one processor, what will happen is that, like this coffee machine, so one will be, two queues can be maintained while he is actually filling that, the other one will take the cup, and the filling process will take some time. So then the next one will be shifted. Like it seems like the both are catered at the same time, but that is not, right? So that is why we say that the concurrency versus parallelism, difference between the concurrent and the parallel processing, you will see that the parallelism, you have the CPUs, several CPUs, so they are utilized by several applications. Here, concurrency means that this is process interleaving and context switching. Switching here to there, you have to keep the main details related to each process and then shift them and run it in the same way. You have the interleaving. Take that other part will be executed after executing another process. So techniques, what enable the concurrent processing? Because now we are not doing that as a user. We are not supporting concurrent processing. We are just starting the processes. We are just initiating processes. But we are not saying that you have to say complete one small part and then go to that my Word application and play some part of the music and go to my Word application and just go to my browser. So you are not going to do that. We are not doing that. But what we need is that everything running smoothly, everything executing at the same time. If the computer people say that software, or maybe the system people, or maybe computer scientists say that if you really want to have a simultaneous processors, you need to have required number of processors, multi-processors required කියලා කිව්වොත් අපි කල්පනා කරන්න ඕනේ බයි කරනකොට කම්පියුටර් එක මම එකපාර මියුසික් අහන ගමන් වීඩියෝ බලයිද මම මියුසික් අහන ගමන් වර්ඩ් ડોකියුමන්ට් කරයිද ආයෙනම් I need to have two processor computer. Then you have to pay that and start, or maybe buy that and use that in concurrent manner. So but that is not happening because of the three main techniques. One is that process interleaving, second one context switching, third one process scheduling. Interleaving is a process or methodology to make the system more efficient, fast and reliable by arranging data in a non-continuous manner. Data or the instruction will be running, or maybe not in a continuous manner. One part will be done and then the other part will be done, right? So likewise you take one part from each process and then execute that part. So the user will not notice that because there's an interleaving. and important, the other one is that context switching. You remember that the PCBs, process control blocks, where it is keeping all the details of the process. So when you try to say now, if you divide the process into smaller parts, when you execute, when the processor execute that part, the outcome, the starting instruction pointer, the loaded data into the registers, everything should be kept and then loaded when the other part of the process is executed. So the context, right? Context of each and every status of the process has to be maintained by the operating system in a PCBs, process control blocks. So that is very important, because otherwise when you start, when the processor trying to shift to the early process again, it will not have the early state. What happened? Where you have stopped? What is the outcome? What was there in the register? What was there in the program counter? So those data should be there in somewhere. So that is what we use for the PCB, process control blocks. And process scheduling is the third one. If I ask that, for example, list down the main enabling technologies supporting for the concurrent processing. So I'm normally asking in that manner. List down 3 main techniques enable concurrent processing. You have to give the answer like this: context switching, process interleaving, process scheduling. Then the second part will be like explain one technique with reference to a common example. So you take that, say whatever the process interleaving, you can say that okay, A and B are 2 processors. So what will happen is that process A will be maybe divided into smaller parts, and the process B also will be divided into smaller parts. You don't have to discuss about the context switching there, because you are focusing on what is process interleaving. And then execute them part by part. This is process interleaving. So we can mention that the context switching and process scheduling is also supported for this execution. Right? So process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and selection of another process on the basis of particular strategy. Somehow you have to select that. Now that is the scheduling algorithms that we are discussing today. Process interleaving. Interleaving is used in many disciplines. It enables mix of processes and executes subsection of each process according to the schedule. So 3 processes are there. 3 process. Then වචනේ පටලෙන්නේ නැහැ නේද? process කියන්නේ අර ලැබෙන task එක. Processor කියලා කියන්නේ ලැබෙන task එක execute කරන CPU එක. So likewise you have the process A, process B, process C. Normally when we are getting separate tasks, what we will do? මෙතනින් දරුවන්ගේ කාටද දැන උයන්න පුළුවන්ද? ගෙදර උයන්න කියලා කිව්වොත් එහෙම පුළුවන්ද? මේ උයන්න පුළුවන් අයට කිව්වහම ගෙදර අද හදන්න තියෙනවා පරිප්පු හදලා සම්බෝල හදලා කරෝල බැදුමක් හදන්න කියලා. දැන් එතකොට පරිප්පු කියලා අරගෙන ඒක ගරලා ඒකට ඕන කරන පොල් ටික දාගෙන ඒකට ඕන කරන පොල් ටික මිරිකලා පරිප්පු හොද්ද හදලා ඒක බාලා එහෙම නෙවෙයි කරන්නේ. You take විතර ඔක්කොම මෙච්චර ඕනෙනවා පොල් එක පාර කරා. right? ඊළඟට ඒ අතරතුර පරිප්පු හොදලා you wash them and put into the pot and then keep in the. So some part is done and then you go to another and you keep the details of that state. මේ ඔළුවේ තියෙන්න ඕන අන්න මේ පරිප්පු එකක් මම වහලා මේ පැම්බෙන්න තියලා තමයි මේ වැඩේ කරන්නේ කියලා. නැත්තම් ආයෙ ෂුට් වෙලා ගිහින් ඒකේ details ටික අමතක කරලා ගියොත් මොකද වෙන්නේ? එකපාරින් හර වෙනවා. එහෙම නැත්නම් ඉතින් ආයෙ කවුරු ආයෙ අමතක වෙලා ආයෙ පරිප්පු හොදලා ආයෙ තියයි. ඇයි අර ස්ටේටස් නැහැ. ඔළුවේ තියෙන්න ඕන now I have in that winner next process is to put some coconut milk to there and get the curry. What is we are doing multi-processing and the concurrent program. මේ ලෙක්චර් එක අහන ගමන් මේක මාළවට වෙන වෙනට concurrent program. වැඩක් නෑ හැබැයි දෙකම හරියට මැනේජ් වෙන්නේ ඒක ප්‍රශ්න. right? එහෙම වෙනවා නම් හොඳයි. No issue. Why we are worried? But there are some additional now හොඳට මතක තියාගන්න ඕනේ තව දෙයක් තමයි අපි හැම වෙලාවෙම කිව්වේ inter process කරන්න ගියොත් multiple processes කරන්න ගියොත් අර who said that we have that important rule, right? We have that Amdahl's law. It says that you can have multiple processors, but the problem is that inter-process communication, right? Collecting the data from the and getting to the final outcome, because the algorithm may have very standard amount of sequential processing, right? So if you can't remember, so what will happen is that there will be some overload because of the multi. Now here also we have that. එකක් ඉවර කරලා බොහොම පිළිවෙලකට ඊළඟ එකට ඇවිල්ලා ඊළඟ එක කරනවා නම් අර inter process communication මේ දෙක shift වෙනකොට මොනවද තියාගන්න ඕනේ එහෙම වෙන්නේ එහෙම කරන්න ඕනේ. So overhead is not there, but the thing is the efficiency will be dropped huge a lot. අර කියන්නේ අර පොලේ මිනිස්සයා the marketer, the seller, if he just cater one person, he don't have to worry about the other things. He will focus on him, get the entire thing, and then no errors can happen, no overhead, because he don't have to focus on any other things, right? So he can cater that person and maybe very quickly he will be able to complete the task without looking into some others. But the problem is that others will not wait for a longer time. So the other processors will also have the same problem if you are having that. So when you have that here, the three processors, if one will be after one finish, if you start the second one, you will see that waiting time for C process is very high. But here you will see that A, C, B, A, C something, some mix because of some other factors. Maybe like you are starting with A and then there's a block, or maybe there's an interruption. So because of that you select two B's, the processor has select two B's and then go to C. So if you consider these processors have several customers, all customers will happy. Irrespective of the end time, what they will look at is that the starting time. The car එකක් හොදන්න කිව්ව එකකට ගිහිල්ලා ඉන්නකොට other example අර මාත් මේක මෙතන දාන්න කියලා කිව්වහම අපිට හරි සතුටුයි. මම ඒක ගත්තා. ඔය ඒක සිත දාලා විදිහ හිතලා. අපි යන්නත් නැහැ මෙන්න එකට. එතන කාර් එක තියෙනවා. Car එක එතන. Because now he has put in that to the bay. Then one person will come and just wash the tires, and then he take another time because he has moved to some other day. එහෙම වෙනවා. හැබැයි අපිට අර යන්නත් බෑ ඉන්නත් බෑ. එහෙම ප්‍රශ්නයක් වෙනවා. right? හැබැයි එක එක අරගත්තොත් එහෙම queue එක ගොඩාක් වෙලා අන්තිම මිනිස්සු යන්නේ. එහෙම කරන්න බැරි process එකක් තියෙනවා. Then if you go to the saloon, you are not asked to okay sit, I will cut here one part and then two parts කියලා එහෙම කරන්නේ නැහැ. මොනසෙ ඉවර කළා තමයි යවන්නේ. නැත්නම් එහෙම පොඩ්ඩක් අලුතෙන් දාගෙන ඉන්නේ. එන්නේ නැත්නම් තියෙන. බැයිද අර මොනසෙ වෙන මොනවා හරි කියෝ හරි ඉන්නවා. Assuming that you have been utilized. නැත්නම් පත්තරයක් තියෙනවා බලවල ඉන්නේ. TV එක දාලා. Somehow we are in the same concept. Right? හොඳට මතක තියාගන්න. ඉතින් අපි මැප් කරන්න මේ වගේ ඒවා day to day examples වල මැප් කරලා ඉගෙන ගත්තොත් විසක් නැත්නම් ඉතින් මේවා නිකන් අර يعني වහ කඳුළු වගේ චිත්ත ඒවා තමයි. තරන්නේ ඉගෙන ගන්න. ඒවා ඉගෙන ගන්න. Right. So it enables concurrent computing with single processor, same as the multi-processor system. Right? So what are the considerations? How to decide which one to process? How to restart with the previous state? These are the two main questions. That what is the process that I have to take? You know, if you go to this diagram, three processes. So interleaving, so multi-program or one processor, multi-programming one processor. So several process are there, and say green color is the execution and the other one is like the idle. So you will see that the first one, because of some reason, blocked, and then start the second process there, and then start the first one again. So shifting between that, and then start the second one is also blocked. First one finish, and then start the third one, and then it is finished and go to the second one. Now, which process should get the priority? How they are maintaining the status, right? So running and block, interleaving and overlapping, multiprocessor, two processors. Multiprocessing, first one is having, you have only one processor, so you can't use that, you can't do overlap the processing or the running time, because you have only one processor. There the second one you have multiprocessor, so two processors. Because of that, real time you can execute two. So that is the parallel execution. Parallelism with the concurrency can be implemented. Because you have two processors, you can't run three processes simultaneously, but two processes, yes. Why? Because it has two CPUs. But now what we are normally discussing is that how to run these three processors in one single CPU, the top one. How you are going to maybe stop them, how you are going to keep the status of each and every stage, how you are going to select the next executable program. Why? So that is up to the processor with the algorithms that we are having. Different algorithms are there in the operating systems, so they decide that. Context switching. Context switching is the mechanism to store and restore the state or the context of the CPU in the process control blocks, so that a process execution can be resumed from the same point at later time. It's very important, right? When you stop that and then when you try to start that again, the context should be the same. Otherwise, they are in a messy situation. The program may have several instructions. So instruction 1 to load A to a kind of a location, the memory location, say that add So then when you are running the code there, sometimes because of the load echo, maybe add, do, compare, store, and then again add, say. So some instruction will take a longer time. Because of that, you may need to stop that and then allocate, right? You can stop here and allocate the CPU to another process. Now the problem is that when you are again switching back to this code, how you are going to execute the next one without having any idea about the previous executions, because these are normally the sequential manner. Whatever the outcome may be affected to the other codes, other instructions. So you may need to keep them with some way of saving the data. Cell state එක මතක තියන්න ඕනේ. අර මුදලාලි doing that, right? that බෝංචි කීයද බෝංචි කොච්චර ගත්තද කියලා ආයේ අහුවොත් මිනිස්සු හරි එකක් කියන්නේ නැහැ. මිනිස්සු මේ තරම් ඉතින් ගුණවත් කියන්නේ. කිලෝ එකක් අරන් ගියා 500 ක් ගත්තා. එහෙමයි. ඉතින් බලන්න ඕනේ. පොලකට මේ බඩුවක් ගන්න ගිහිල්ලා ඔය ගිහිල්ලා බලන්න ඔය මේ නීගොඩ ආර්ථික මධ්‍යස්ථානයේ ඉක්මනට ගිහිල්ලා බලන්න දැන් ඔයගොල්ලන් ඉතින් තව අවුරුදු 6කින් 4කින් ඉතින් කොහොමත් ඔය යන්න වෙනවා. කොහෙ ගියත් මං ලංකාවේ ඉන්නේ නැහැ කියලා හිතුවොත් කොයි ගියාම විතරවල ගෙදරට ලෝඩ් එකක් දාලා යන්නේ නැහැ කවුරු. මේ දීලා ඔය වගේම තමයි. හරි ජොලි කියලා හිතුවට එහෙම ජොලි නෑ. මොනේ මෙහි ඉන්නදී නම් අපි දානවනේ ස්ටේටස් දානවා Facebook වල started job at this company that company කියලා ෆොටෝස් දානවා. පිටරට ගිහින් එක්කෙනෙක්වත් දානවා දැකලා තියෙනවද? ඇයි? මොනවාද බෑ. අපේ ලංකාවට ඒ ජොබ් ගැලපෙන්නේ started job at that cleaning company කියලා හැම දාන්න බෑ. දාන්න. අපි ගියාම අපේ education level එකටම they are not offering the jobs. Whatever the job you have to do that. Maybe you can throw off some other way. Right? ඒ හින්දා එහෙ ගියත් කොහෙ ගියත් මේ වගේ වැඩවල experience අරන් තියාගන්න. Go to a market අම්මලා අතට ගිහලා මම අද ගිහලා බඩ් ටික අරන් එන්නම් කියලා ඉතින් සල්ලිත් නැති කරගෙන ඒ කොම් කරගෙන එන්න එක දවසක් ගියාම ඊළඟ දවසේ පුළුවන්. මේ මොනවද මේ කියලා තියෙන කියලා කියයි ගෙදර ගිහින්. එහෙම ගිහිල්ලා තියෙනවා කවුරුත් නෑ ඔයගොල්ලෝ යනවාද පොලකට ගිහිල්ලා නෑ තියනවා නෑ ඇත්තට මං අහන්නේ නිකන් මම ඉතින් ඔය කාලේ යන්නේ නැති වෙයිද කඩේ ගියා ගිහිල්ලා තියෙනවද ෂුවර් ගිහිල්ලා තියෙන මේ කොටට එහෙම ගිහිල්ලා තියෙනවා මාර්කටිං මධ්‍යස්ථානට ඒකට ගිහින් බලන්න කොයිතරම් අමාරුද කියලා how they are actually doing this multi-processing multitasking. This is context switching and process interleaving is highly deployed there. එකක් අහනකොට එකක් උත්තරයක් දෙනවා එහෙම තියෙනවා experience ගන්න. So now because of that the now context switching is that you have to maintain. I think you should agree with this. After executing up to that whatever the outcome should be stored if you are just starting that in some other time. මේක වෙන වෙලාවකට නම් ඉතුරු ටික කරන්න you have to keep the details. That is context switching. Context should be completely stored in a process control block, PCB. Okay? So it enables multiple processes to share the single CPU. Context switching is an essential part of the multitasking operating system. Very important. Context switching example, idea. Two processors running, process 1, process 2. Process 1, process 2, so there are interleaving, two processes are there, context switching. So it also needs some time. It also needs some, this is overhead, right? Because you need to take the start details of the process and it should be done by the kernel, right? Kernel model. Because it needs some time, you can't immediately start the other process because you need to have the timer interrupt, P1 preempted. We will discuss that later, but it is actually blocked. Context switch to process 2 because the processor has to read the details and save the details of this and get the details of the next one and then execute the process B or the process 2 and then there's another interruption system called trap or something and then because of that it has to save the details of the process 2 and then again load the details of the process 1 stored here and then it is going in that manner. Can be interrupted because of the IO driven activity, loading to the or maybe saving to the hard disk drive or maybe getting details from the network, whatever the things there. So context switches are computationally intensive since registers and the memory stack must be saved and restored. So it made that computationally intensive. Computationally it needs more time. So it is some overhead. You should agree with that because you are keeping the status, you have to store the registers and the memory status in somewhere in the PCB if that will be used when the same process started again. So if this is very high and ඉතල බලන්න මේ ටයිම් එක ගොඩාක් වැඩි නම් ඕවර්ලෝඩ් එක වැඩි නම් මෙහෙම ස්කිප් කර කර යන එක තේරුමක් නැති. Because this time is cumulated, adding together, right? එතකොට මේ මුළු මේකම කරලා ඉවර වෙනවට වඩා වැඩි වෙලාවක් මේ process interleaving එකට එන්න context switching එකට ගිහිලා තිබුණොත් so it is a waste of the time. Unwanted task එකක් තියෙනවා. හරියට මෙහෙම සිද්ධියක්. මෙතන කියනවා කෙනෙක් there's a person in the computer department, computing faculty, there's another person in the main game. So they have to perform task. මේ task එක ඉවර වුණාම භාගයක් චුට්ටක් ඔක්කොම ඉවර කරලා ගේට් එකට කිව්වොත් ඊට උඩ කරනවා. ඒක වෙයි. No process interleaving, no context switching. එමෙන්න හිතන්න මේ task එක පැය කාලේ task එකක් කියලා. මේ task එකේ විනාඩි 5ක් ඉවර කරලා අපි දුවලා ගිහලා ගේට් එකට කියනවනේ ඒ විනාඩි ඉවරයි කියලා. ඒතකොට එයා එතන විනාඩි 5ක් ආයෙ කරනවා. ආයෙ මෙතෙන්ට පණිවිඩය අරන් එන්න. ඒ එන ටයිම් එක විනාඩි 5කටවත් වැඩි නම් වැඩක් නැති වෙනවනේ. මේක ඉවර කරලා ඉවර කරලා ඉවරයි. So if this is computational intensity, right? So then the usability or maybe the efficiency of the context switching is a waste, right? But normally now it is not that. So this considerations in concurrent computing, sometimes we may have deadlocks, sometimes there can be starvation. Deadlocks because sometimes there can be a process, two processes are there, one is actually one's output is required for the other one. So the other one's output is required here. I think you have seen the deadlocks. The deadlocks are normally in the roundabouts, junctions, ඒක ඇවිල්ලා මෙතන පාරෙන් බ්ලොක් වෙනවා මේ මනුස්සයා මෙහින් අරහෙට යන්න හදනවා එයා එහෙන් බ්ලොක් වෙලා ඉන්නවා මෙයා ඇවිල්ලා මෙහෙට යන්න හදනවා මෙහෙට බ්ලොක් වෙනවා මේ මනුස්සයා මෙතනින් දාගෙන බ්ලොක් කරනවා deadlock. You can't go there because this is there. He can't. There can be some other vehicles here, right? You can't move. So this is completely deadlock. That can happen in this way because a situation in which two or more processors are unable to proceed because each is waiting for the one of the others to do something. Starvation, a situation in which a runnable process is overlooked. What do you mean by overlooked? Neglect. Overlooked indefinitely. By the scheduler, although it can be proceed but it is never chosen. Why? Because of negligence. That because that now process is starvation. You can scheduler not given the chance to do. So the process has not been selected. It is everything done. No deadlock, no waiting for any other input or output, right? IO waiting, not there, but it is ready, but not has been chosen. So those are important things to consider. So why process needs to be scheduled? To improve the performance in the system, right? Scheduled. So it should be scheduled now properly. Who is going to do that? Because some of the processors are CPU burst, very high CPU requirement is there. Some are IO burst, right? And then, so likewise, different requirements are there. Processors has different requirements, processing requirements, IO accesses. So if you consider anything like, say, if you consider like YouTube, again the network is there because you have to get the network details. The data from the network. Some are there where the program is waiting for the user inputs. Otherwise, you can't proceed, right? So it is in a deadlock. For example, if you are doing a quiz, now everything loaded, but the CPU is not doing anything on the process because you have to click kind of a button. Then only the computer or the processor will look into that and maybe load the other page. So you have to, user has to give the input. So again that is a IO, input output, waiting thing, right? The speed of each sub-activity is different and they need different time cycles. So there are several requirements and then there is a long clock cycle waiting I/O. Sometimes the processor is idle and need to be wait until the I/O complete, input output. So there will be reduced. This will reduce throughput, reduce the performance, because there are several types of applications, type of processors there. Some are very much highly intensive, some are very much lightweight, some are waiting for I/O, some are CPU burst, because say now sometimes there can be applications like say fingerprint matching applications, or maybe something you are calculating, you are doing some kind of a huge calculation. So CPU is highly utilized. So then no one will be able to use the CPU until that process finishes. So sometimes there can be applications like waiting for a user to input their name and click the process button. So still that process is running, right? The browser is working, and then everything is loaded, getting the requirement from the network. So the web page is loaded, but waiting, it can be waiting for a longer time until the user click the button to proceed. But those are applications, processors. Memory has been utilized to applications. If you go to that process list, you will see that the Firefox is running. Why the Firefox is running? Because it is getting a web page. User has to insert the username and the password. So it is I/O waiting, input output waiting, especially from the human. So human input and outputs, computer has no control, because user has to proceed. But there can be some other I/O waitings, like say from the network, from the hard disk drive. So those are done by the network, no human involvement there, and done by the inside computer reader, or maybe the controller, I/O controllers in the computer system, operating system. So types of processors, I think you are aware that sometimes the applications are there, it is waiting for the small portion of the CPU will be taken, and then again waiting for maybe writing files, and then it is I/O waiting, and then again will do something, and then again waiting for a longer time for the output. So CPU bounded processors, where the CPU, you will see that the color, the green light color and the ash light, two types. Ash color is waiting time, right? So then you will see some processors, CPU bounded processors, hardly any I/O, mostly CPU activity. Example, GCC, scientific modeling, 3D rendering. Examples. Useful to have long CPU burst, could do with lower priorities, because high priority has to be, it says that, we will discuss that later. But why it is saying that the high priority? Because now word processor kind of application, what will happen is that you give the priority to that process, and then immediately it will take the CPU, and then what will happen is that there will be I/O. So then if you can run this kind of a low priority application without any issue, after that you can do that. Because this is waiting, we don't have anything, because that application had to perform that and become a ready application. So can you remember that the life cycle? Ready, running, I/O wait. Ready, running, I/O wait. Start is there and the termination is the other side. Very easy to remember. So then it is not until it is becoming the entire complete thing, it will be either in the I/O waiting or in the ready. So meanwhile, the CPU can be utilized by the CPU bounded processors, or maybe very high CPU intensive application. Even though it is low priority given, it will be executed because these processors are waiting for I/O. So value of the process scheduling, now you will see, because of that CPU idle. If you go to the process 1, you will see that there's no interleaving. There's no simultaneous processing or concurrent programming. You will see the first one started, 3 cycles were waiting for I/O, and then started and completed. After 8 cycles, it is completed. So you will see that the CPU waiting, it should be scheduled. The next one, whatever the required one, can be schedule up to 2 to 4, 3 cycles. 2, 3, 4 cycles can are idle because CPU can be considered as the most important resource. To complete these three processes, it has taken like 20 or 24 cycles, but out of the 24 cycles you will see that 3 and then again 6 and again 1, 3, 6, 10 cycles the CPU was idle. 10 out of 25 cycles, 24 cycles, 10 cycles idle, CPU idle. So it is based on the CPU. So rather than the scheduler or whatever the operating system should be able to utilize the application or maybe the CPU by doing some kind of a context switching and allocating that time for another application. And then the next, when this is ready, you can again shift that and do that, because ultimately what will happen, the programs can be executed maybe within 15 or 16 clock cycles, because some of the overhead will be there. You can't execute by just 24 minus 10 within 14. That is the ideal situation, but it cannot be done because you know that context switching overheads are there. So you need some amount of time for the context switching. Then ultimately you will see some kind of overhead there, but it will not be. It will be still fruitful, right? Okay, now we'll have a small break like 10 minutes and then we'll continue, because we have more to go. At least we have to do some several, because now we have very important thing in the scheduling algorithm. At least we have to do today, right? We'll do that. Have a short break like 10 minutes. Do you have anything to any question? Anything that you are not very much clear? Please let me know. ඔයගලන්ට free time එකක් තියෙන්නේ කොයි වෙලාවද සාම? Friday එන්නෙම නැද්ද? නිවාඩු දවසක්. Friday වැඩ නැද්ද? වැඩ නැහැ. Friday ඉස්සර වැඩ නෑ දැන්. ඒතර Wednesdays වල lectures නෑ ඒක. ඒතර තියෙන්නේ Monday, Tuesday and Thursday. එදා full utilize.
Tuesday hours है. Tuesday hours है free.
Tuesday hours है. දැන් Tuesday හවස ලෙක්චර් එකක් හදිස්සියක් දානවා නම් එහෙම නැත්නම් ටියුට් එකක් දානවා නම් කාටද කියන්න ඕනි කියලා මම එකක් ළමයින්ට පණිවිඩය දෙන්න පුළුවන්. මගේ නම්බර් එකට පොඩ්ඩක් මට මැසේජ් එකක් දාන්න WhatsApp වගේ එකක්. ඔයා ටීම් එකත් එක්ක ඉන්නවනේ.